Well, I had this fantastic job, and over the years, I put together a fantastic portfolio of ideas for projects for kids, especially technical projects like in the course that I taught at ISB called Industrial Design. I had a chance to explore every day. I was down in Chinatown on my motorcycle going down these little streets. And in Thailand, we call these streets sois. So I found a company, and it was just a total adventure. I'd go inside, and I found out the company was 103 or 104 years old, and they sold just about every ball bearing that you could buy. And I just went through and looked at the sizes of ball bearings. They had enormous ones, about 3 and 4 inches across, that was used in heavy equipment. But they also had balls that were more like an inch and a half across or an inch and a quarter across. So I decided to buy about 75 of them and give each of my students 5 that took my classes in industrial design. I came up with a project that they could design on a program called SketchUp, which at that time was free from Google. And it's a great drawing program with 26 tools that you can actually comprehend in about half an hour of working with the program. So I asked them to try to draw their plans with this computer program, and some of them chose to make hand drawings, which were not only acceptable but amazing. I mean, they had to do the drawings in perspective so I could completely understand the machine, and then I would give them some suggestions. In this project, the whole idea was that the machine would pick up the ball again. So when it reached the bottom of the path that it took, by magnets or by some mechanical means, the ball would be picked up and delivered to a track that was made out of bronze rod, brazing rod. Now that rod comes in 1 meter lengths, and I bought a load of it, and I showed the kids how to solder tracks together that the balls could follow. And I gave them a number of ideas. Most of the kids used wood to build their machine. Some kids used just the bronze rod by itself. Once they learned how to solder with soft solder, a whole world opened to them, and a lot of them chose to use the lathe to make wood wheels and parts for their machine. So some very simple tools were used. Of course, they used a drill press, and I showed them how to use Forstner bits. And then most of the other things they made with bronze rod. So the hand drawings were elaborate. Some of the kids could draw so beautifully, actually taught themselves to draw, and some of the drawings looked like something that was made by Leonardo da Vinci. And one kid even made wheels out of gears. He made the wheels into gears that meshed with each other, and all the teeth on the wooden wheel were made with a bandsaw. So the children learned so much about using tools to manufacture parts for their machines. When I came to grade these things, I graded them on the ones that were the most interesting. In this machine, the kid came up with a wonderful way of delivering the ball to an arm that would deliver it to the track. Each student came up with their own idea of getting the ball down a bunch of chutes or tracks, and it was absolutely fabulous. This is when you go in a room and see this. This is when learning looks like what it should be. Incredible fun. In this machine, the machine has a ball sorter for the track the ball takes. So there's a Y-shaped piece of wood that decides whether the ball's going to go to the right or the left of the machine, and each path is a different path down. These kids, do you know how old they are right now? They're probably around 30 years old, and none of them have forgotten these kind of projects. I always prided myself in coming up with the very individual ideas that would stimulate a person to think. And I think that's the beautiful part of my class. Some of them came up with totally original ideas, like this stairway, which delivers the ball to the next stair and reciprocates it up and down as the ball travels up the stairs. So a lot of these ideas were wonderful, and this was the 9th to 12th grade. All my classes are mixed and not sorted out by grade level. So some of the younger kids came up with better ideas than the older kids, and it's just a wonderful place of industry. When kids come in the classroom and they go to work and they set up a machine and they're cutting away, it's just, what can I tell you? It's as close to heaven. I had the most amazing classroom at ISB, and it was often the showcase of the school, so that when clients or parents came to the school, the principal would bring them by my classroom to watch them and see how engaged they were with solving problems. Many of these kids actually were so influenced by these projects that they decided to go into mechanical engineering. And of course, others chose chemical engineering. But I had an influence on the kids that design was a wonderful way to make a living. And they really, really loved it and stimulated it. There was actually like a waiting list, a queue to get into my classes, so my classes were always full. I had about 17 or 18 kids in a full class, and then I had some other classes where I only had 12 kids in a class. When there were less kids, I, of course, could give them tremendous amounts of attention. And mostly I was just going around suggesting things they could do or watching the way they work and making sure that they work in a sequential thing, because if you do the wrong things first, it stops you from doing things that you want to do later on in the production of your idea. Some kids use cams. They came up with incredible ideas, and I just love it. It's like a children's playground. There's so much creativity going on. So I don't really show them a lot out of books. I taught them things about physics and ideas that they could explore, and then I sort of turned them loose. I told them craftsmanship is a great and important part of the machine, and it should look really sort of exciting and interesting, and all the parts need to be finished and worked on, so they worked on most of their details. Making a kinetic sculpture like this is so involving. The kids loved it. A lot of kids used magnets. Some kids used a reversing relay to reverse a motor that would pick up the ball and then drop it down. So there's so many different ideas, and this one student who made gears out of wood, he had to actually cut those gears with a bandsaw. So he had to refine each tooth so they meshed with each other. All of them learned soldering, soft soldering, electrical soldering as a skill. So there's so much that they gained from this. Also, a total respect for the machines and what they could do for you. So I took them, my assistant and myself, take them through all the safety hazards of the various machines. We explained a router. I showed them what electric circuits look like. And if they involved electricity, they all did, they had to learn how to draw a proper looking schematic for their idea, which used reversing relays and low voltage. But they were so into it. I mean, you just see these kids watching the machine work and then seeing what they needed to adjust to make the machine foolproof. And that's something I hadn't really spoke about. The machines, in order to get a successful grade, I mean the highest grade, the A and A plus, the machine could not drop the ball out. So I watched each machine for about a minute to see if it was 100% foolproof. And that was a very great bit of the challenge, because if a ball had inertia behind it and it was moving too fast, it would sometimes drop out of the machine, and that meant that you couldn't get that A that everybody's after. I actually hate grading, but I love work, and my classes were an absolute symbol of learning and symbol of what learning should be. My class was an icon for learning. And all the classes that I taught, and even today I'm teaching almost trade level jewelry, and it's the work that is so incredibly rewarding. So watching these guys solve problems, some of them really grew to have like romance for the tools, for a router or a bandsaw or a scroll saw. So these machines got a lot of respect, and I was comfortable with every student working safely and watching them work out their ideas. I didn't have to worry that some unexperienced kid would injure himself on any tool, because we spent weeks going over the safety for these machines and what could possibly happen to you if you weren't alert and you weren't using the machine in a proper way. Motors, I bought hundreds of them in all different speeds, and it was up to the student to choose whether he wanted to use a 220 or a low voltage motor. Some of them didn't know that with DC you can reverse the voltage, the current, and the motor will reverse. Industrial design was one of the best classes I ever taught at the school.